All right, so solids of rotation. We're going to spend 3 days on this. The first day will be like all entirely solid. The second day we'll have like two lines, and so there'll be holes in the middle when we rotate it. The third day we'll start rotating around various different lines. But let's talk about solids of rotation first. So we're going to take this shape, 2 plus x cosine of x, in between -2 and 2. And we are going to rotate it around the x-axis. So I can't draw that there, but here, like our cross section would look like that. There, our cross section will look kind of like that. Out here, it'll look kind of like that. And once I get rid of that, we can take a look at the graph of the bottom half of it. So it's going to be kind of like a vase-ish looking thing with like this part. This part is the bottom, and this part is the top. Except it's going to be solid. There's no inside of this vase, so to speak. So the way we want to find a volume of this is by cutting it vertically. All right, so with integrals, we break things up into rectangles normally when we're trying to find the area. When we break up these, we're going to find a volume of each of these. We're going to basically, instead of pretending these are rectangles, we're going to pretend they're cylinders, right? Rotated around with a center of the x-axis. So like this shape, but that's just the side of a cylinder, essentially. Kind of like it'd be like look like a coin standing up or something like that. So let's talk about area and volume. So cylinders. The volume of a cylinder is area of the base times the height. The base is going to be a circle, and the height is going to be dx. So our area is going to be pi r squared, essentially, where pi is pi, and the radius is this distance. Right? That distance is just the value of the function minus 0. So it's just the value of the function. The height is going to be our dx, and that's this distance right there. Right? That's what we're shrinking to 0 as we take the integral. So if that's our area, our volume is pi times the value of the function squared dx. And then we can take our integral from -2 to 2 of pi times 2 plus x cosine x squared dx. And we get 52.429. And that is volume of solids of rotation.